Welcome back to Robinson's Automotive, toolsandtime.com. Today, I'm going to take you back in time a little bit with this 96 Toyota Corolla. The vehicle's in great condition. It was passed down from a generation. And the guy loves the car, but he's been having trouble getting it through emission inspection here in Pennsylvania because the check engine light's on. This vehicle came in and it was at another repair facility, but it had a code for EGR, inefficient flow. Okay, so the vehicle was going through its drive cycles, it was commanding that EGR, and it expected to see certain changes and whatnot, most likely through the oxygen sensors, and seeing how things act when it's activated, okay? So it depends on a few things to be working correctly to complete this cycle, right? And something evidently wasn't working. Was it a restriction? Was it something mechanical, not moving? Was it something electrical? Well, I can tell you, there's been a lot of parts replaced, and I'll be taking you in there. But I want to show you what I did and how I got to where we are today, and that's the vehicle EGR system now functioning correctly, as it should. First course of action, as you can see, I have an old component sitting there. I have a vacuum pump sitting here. And we have some new parts that are showing in and around this EGR system. Want to make sure everything's hooked up correctly. So this one happens to have a vacuum hose routing diagram, right? So we have our EGR valve. We have our EGR solenoid, we have our EGR vacuum modulator, and then we have our ported vacuum hoses. So we wanted to make sure those are good, so we verified. Okay, this one goes to P, this one goes to R. Yep, perfect, that matches. Everything looks good as far as the routing. It matches the diagram. Step one. Okay. Sometimes I've had, in the past, these ported vacuum lines get plugged up. So I want to test to make sure I have good vacuum here. But how about if the EGR port is restricted, or if that EGR valve that's old is just not functioning? So what I would like to do is just pop off the hose going down to the EGR, which is this guy right here. You can see it goes down to the top of the EGR. Without even starting it, I got my vacuum pump. We're gonna hook it up here. We're gonna draw a vacuum. Okay, the diaphragm is holding vacuum. I release it. I can hear the mechanical portion of the valve moving. With that unhooked, I'm gonna start the vehicle. It's warming up still, but we're gonna take this. We're gonna put it on the EGR. Then I'm gonna add vacuum. I'm gonna apply vacuum. All right, did you see that? Or hear it? Big difference. So with that quick demonstration, it pretty much shows us mechanically, okay, our restrictions aren't so bad to cause an issue. I mean, it still can, so don't cut yourself short at that point. I mean, there still could be restrictions in that port, but we know that it reacted pretty severe, that you're gonna see a change in something, which is your O2 sensors. When that thing gets applied vacuum, you can go about this in a different order, but this is just the order of which I went at. So next what I wanna do is test this vacuum. And so we'll do that using this vacuum gauge, and we'll simply pull one off of this valve, and we'll hook it up here. And this is what they call port vacuum, so it's gonna look a little bit different, but I wanna show you how that works. All right, now one might start this up and be like, oh, I have no vacuum here, that's why it's not working. But what you gotta understand is that this is port vacuum, so depending on where it's at in the throttle body, it's gonna act in a different way. So this one, I'll bring it up to probably say 2,500 RPMs, and we should see that vacuum respond. Okay, it's just where it's located in relation to that throttle plate. All right, so we know that one's good and open. We put that back on here. We have 2-port vacuums here, so we might as well check them both. Same thing, you gotta bring that throttle plate open. Usually 2500 is a good testing point if you're monitoring your sensors, your O2 sensors and whatnot. Not as strong as the other one, but it could be in relation to where it's located on in that throttle body. But we see that it is open and it is responding. Next, I'm going to take the vacuum hose off of the solenoid, right? Because the vacuum isn't making it to the solenoid. If the solenoid fires, it's not going to have any vacuum to control it. Now we have a hookup to the modulation valve on Q, and that's the one that supplies the solenoid. So we're going to do that same test, bring it up around 2500. And as you've seen, we had vacuum. So when it's above idle, around that range in which it's going to run that monitor, and that valve opens, it's going to be enough vacuum to actuate that valve. I hope that makes sense. So we have everything here that we need for this to work. There's only one other thing that could be missing, and that's the control of that solenoid, or a bad solenoid that just isn't firing, but we know it's been replaced. All right, key on, engine off. So this next test is where I went next. I wanted to see if I could bidirectionally control the EGR valve, right? And then at that point, I could run a test, I could watch the response of the O2 sensors, and kind of put it through a Bay test of sorts. Even though this one doesn't have that function, you can still monitor certain data and say, okay, this is going to go through the monitor, right? So we're still missing something evidently. So let's see if the vehicle is able to turn that solenoid on and off, right? So next we went to actuator test and we went to EGR on and off. All right, so you can see the message that comes up here. My other scan tools, I couldn't even get this far with it. It would just say this option is not available, blah, blah, blah. And it wouldn't allow me to do any bidirectional control on any of the systems. So I was like, okay, at least we're getting somewhere with the Snap-on. And I gathered this after talking with a good friend of mine, Keith DeFazio. I believe I pronounced that right, but AKA New Level Auto, when he was a mobile technician. He's like, try your Snap-on. They have made a lot of changes and hopefully that'll correct it. Because this is a 96, it was right in that window where everything was becoming a standard with OBD2. So limited functions. So we're gonna hit okay. And then once it prompts us to the next state, it wants us to raise your engine speed to 2,500 RPM. With the EGR system activated, expect to see fuel trim adjustments to compensate for the EGR. Remember what I was saying about the O2 sensors? They're gonna look at the air-fuel ratio. You can monitor your fuel trims based off of that data and see it compensate for the EGR opening. And that's also what the computer sees. So as part of a test, I don't know 100% of the system operation. Continue. It's going to collect the data that it thinks is going to be helpful for you. This is a function of the Snap-on Zeus. Most other scan tools will just allow you to select the data PIDs, where this one brings up the most relevant EGR. So EGR is off right now. So if we command it on, key on, engine off, we're not going to see any data change as far as O2 oxygen levels and stuff like that. But we should hear an audible click. Because without the engine running, let's face it, it's not monitoring anything. And without it off of idle and the throttle plate opening, you're not going to see any vacuum or enough vacuum to open that valve anyway. So what I'm listening for now is an audible click coming from that solenoid, because I know that solenoid is good because I bench tested. That's one thing I'm probably going to leave out, but I can show you everything else. But just take my word, all the new components that they put on there, test out okay. So click on. and I hear nothing. So that was my first test. I'm like, okay, but all scan tools aren't bulletproof, like Keith said, and also the scan tool also told us that sometimes this is an optional function. So I was like, oh man, maybe I'm just not able to command it with the scanner. That stinks, right? Guess I'll have to pull out a wiring schematic and see exactly how this works. So highlighted here, you'll see I have the power. So this is positive side, and I'm just scrolling over to see what else it feeds, and everything highlighted is branching off, going to other components, oxygen sensors, electronic fuel injection. So many things come off of this. Actually, it's powered. You'll see once I scroll over, it gets its power from the EFI relay. So if that fuse was blown, if that relay wasn't working, it simply wouldn't run. So that's telling me, okay, most likely I'm going to have power at the power side of that solenoid. So our best course of action right now, this is just where the power ties in. That's where it tees in and supplies that whole entire string, you know? So, and as you can see, this is the EFI relay. And yeah, the vehicle simply wouldn't run with if that circuit wasn't powering up the rest of the components. So at this point, I'm like, okay, I think we just go right to the source, right to that solenoid valve right here, and do some testing. And as you can see, it has power supplied and control ground. So the computer is going to pull the coil to ground. So it's going to supply to ground, a negative to that coil. And so I'll tell you right now, we're going to skip the test. Or actually, you know what? I'll show you that test. So at this point, I grab my test light, right? I know I'm supposed to have power present on one side all the time with the key on, right? I won't see a ground at this point unless I activate it, but we still don't know if my scan tool is capable of bidirectionally controlling that solenoid. I want to unplug it, right? All right, so with that unplugged, I grab the test light. We're gonna hook it up to ground, and if I find a good power source, the test light's gonna illuminate. Ground aren't gonna do anything because it's not completing the circuit, right? So if we find a positive, it's gonna illuminate this test light. So got nothing here on this terminal, and bam. So we have power. So the only other thing that this thing needs is a controlled side ground. So if I apply ground to this with this plugged in, we should see that actuate. But hey, it might be a bad coil. It might be a stuck pintle. It could be anything. So if I bidirectionally control it and I turn it on, it should apply ground. Let's do just that. Bring our scan tool over, but now we're gonna have to switch this to positive. That way, if I find a good ground anywhere, the test light will illuminate, right? So we know we have power here. So I'm gonna hold this to where the ground should be, right? And then I'm gonna turn it on. Nothing. It doesn't. If there is anything there, it's not enough to illuminate the light bulb. If it can't illuminate the light bulb, as you can see, if it can't turn that light bulb on, it's never gonna turn that coil on. So I'm like, okay, we have no control with the scan tool, but how do I know that the scan tool has a capability? I'm kind of at a dead end right now to see if, I don't know if the scan tool really has that function. I mean, it says it is, but it evidently is not. So I hooked this back up, plugged it back in, and I was like, okay, let me try a different bidirectional control. Let's see if I'm able to do anything with this. So I want you to listen closely. So I went to fuel pump, and I'm gonna command the fuel pump on. So this is another bidirectional control. I'm like, let's see if anything is controlled by this computer. Let's see if this is able to actually control anything bidirectional, or if it's lying to us. So listen closely. And as you heard, the fuel pump turned on. Oh, let me cancel that. Do it again. So I was able to control that, and I was like, oh, let me see if I can control the idle air. So with this one, I'm gonna have to start up the vehicle. It's making a difference. So what this confirmed for me is that I can control the idle air. There you go. I exited out of it too quickly, so now it's trying to compensate. But I can control the idle air, I can control the fuel pump, but I can't control that darn EGR. So at this point, I'm like, okay, do we have a broken wire? Is something on the ground side broken? I wiggled the harness. I couldn't, with it command it, I couldn't hear any audible clicks or anything. So then I'm like, I'm gonna go right for the engine computer and I'm gonna back probe it and see if I have ground switch in there. So looking at the schematic, I found that it's the black wire with white trace. Okay, so looking at the EGR solenoid, and if we follow it back, you'll see I'll highlight the black with white trace. We're gonna see where this one goes. As you can see, it's not branching off anywhere. It's just going straight. Ends up at the ECM, the engine control module right here. And that's located behind the center of the console. So we're gonna get in there and we're gonna back probe it like I'm getting ready to demonstrate for you. And we're gonna see if I have ground present when I command it here, or if I ground it, if it actuates the valve. I have it back probed, still hooked up to the ECM, and I have this alligator clip wire hooked up to that back probe. All right. Want to know a quick way to test this circuit? So at this point, it just needs a ground applied here, and we should hear the audible signal out front. So let me turn the key on. I know I have that clicking in the background, but I want you to pay attention and listen close and see if you hear what I hear. Now I'm going to move you out front, and I'll tell you when I go to ground it. And this is a noise that I was hoping to hear when I do bidirectional control. I have you looking at the solenoid. This is where that clicking noise is going to come from. I'm going to apply ground for the computer inside the car. Okay, you ready? On, off. On, off. Okay, so what's that tell us? Well, that tells us that our wire integrity is good all the way to the ECM, okay? How can I test this? So I took my test light, I hooked it up to a known good ground. I'm gonna hook this up to my test light. What I want you to see is now the test light is in the circuit of that coil, okay? So we have power going to that coil out there, right? Picture that coil as a light bulb. A clear light bulb, you'll see it'll have power on one side. It'll have a filament that connects to the ground side, but if there's no ground there, that power is gonna travel through that filament and go down in search of a ground. And that's essentially what you see happening in here. This test light isn't strong enough to act like a complete ground, but it's kind of there and it's able to illuminate, but it's not able to turn on that solenoid valve. So you might be asking, like, why would you use a test light on a ground side like this to try to find ground with it hooked up to ground the way I have it? Well, what I was doing was trying to protect the ECM, and I use a test light to apply ground to try to get a solenoid to activate. So we're not pulling it 100% to ground. Otherwise, this would not be illuminated. So therefore, with that mindset, I'm like, okay, so if I command this on, if everything's working correctly and it completes to ground, the test light will turn off, right? So if it goes through a drive cycle, or if I activate it with my scan tool, that test light should turn off, saying, hey, you know, you have a good ground, being enough to pull all the ground and take away all the power, essentially is what we've seen. But when I command it on with the scanner, go ahead, command it on. All right, it's on. As you can see, it did not pull to ground. We want to see it pull all the way to ground and hear that solenoid click out there, which we're not seeing. So then I was like, well, it still doesn't confirm that my scan tool is even capable of commanding it. So what I decided to do was leave this test apparatus hooked up exactly the way you see it and drive the vehicle through an entire drive cycle. So I cleared out the codes and I started a fresh drive cycle. I drove it, and within 10 miles or so, the check engine light came on. And this test light never once turned off. Scanned it, and sure enough, we had an EGR low flow code that came back. I was like, well, how is that possible if it never even commanded that EGR to turn on in the first place? So at this point, I tested all my powers and grounds, and like you've seen, everything else is working just fine. It's just this EGR solenoid will not fire. And I know it might seem odd, and it might take a little time to wrap your mind around it. But while I'm driving it through a drive cycle, it takes my scan tool out of the equation, all the bidirectional controls, and it allows that computer to do exactly to what it's programmed to do. And if it ran that monitor in order to throw that code, I should have seen that light bulb. If it supplied ground, I should have seen it go out for the time that it takes to run that cycle. And that test light never once went out. That told me there is something wrong with the driver inside that computer. And I felt safe at that point, ordering my flagship one computer and hoping for the best. Through the power of editing, here she arrived. A week later, our computer from Flagship One. Not a sponsor, but it was the only place that I could find one. And what I simply had to do was look at the numbers and give them this number plus the VIN, and they were able to supply me with this ECM. So what we're going to do now is we're going to hook this up, and we're going to see if it fixes our problem. Were we right? Did we do everything possible in confirming or calling this computer? Was it worth the investment, the time, and the energy that it took waiting and explaining this to the customer? Battery disconnected. You see what I got back here? And that's that black with white tracer. I know you probably can't see it, but I had it lightly back probed, and then I had this hooked up. Okay, we're going to take all that out. We're going to take our new, refurbished, whatever it might be. It could just be used and tested, as far as I know. I have no clue, but we're going to hook it up. We're going to plug everything in. We're going to leave everything unhooked. So no more jumper wire, no more nothing. First, we'll confirm that the vehicle still starts. Okay. No more check engine light. So, but that would happen if I cleared it and it didn't run its cycle. But more importantly, go into activation test, go to EGR, continue. Yep, we know all this stuff. All right, deep breath. Bam. Let me take you in. Bam. She's working. Awesome. 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 And then for the sake of demonstration, I hooked everything back up with the new ECM, and I back probed the control side ground for the EGR solenoid, right? And as you can see, I have it hooked up just like I had it for the test drive. Now, just for demonstration reasons, I'm going to show you what it would have done if the computer went through a drive cycle and actually commanded that ground. So we're going to turn it on. As you've seen, the light went off because we completed that circuit. We pulled it to ground. That computer is pulling it to ground, so it has no more power remaining to turn that test light on. You can see it come back on when I turn it off. And then when I turn it on, it pulls it to ground. It can no longer illuminate that bulb. So that was exactly what I was looking for. That was my mindset while I was test driving. And that's how we came to this conclusion. Before we take on a test drive, remember when we looked at that original scan data, when we went to do this activation test, it said you can monitor the short-term fuel trim. All right, so now we're inside the vehicle. You can see it's hovering somewhere around 0 and 3%. So now we're going to look at the engine RPM here. I'm going to bring it up to about 2,500. You can see how our trims look different. You can see where the graph is pretty much painting itself, and now we're going to turn it on. Here to change in the engine, I can feel an evident difference in the way the engine's running. Turn it off. Hear it clear out. You see how pointy the graph is? Pretty much showing that, yeah, everything's hunky-dory. Fuel trims are pretty steady. Now we're going to turn it on again. See that change? I can feel the change in the engine. It should go through, and that's what we're gonna do. I'm not gonna put everything back together yet or whatnot. There's no sense of having the test equipment hooked up the way I had it before. But what I can tell you is that I'm gonna check to make sure there's no codes current, because this is a different engine computer, right? We're showing no codes current. We're gonna go to generic functions. We're going to go to readiness monitors, and I'm just going to show you that our fuel system is completed, catalyst is not completed, evap is not completed, AC not supported, O2 sensors test completed. So it determined that those are okay. Misfire, no misfires, test completed. Components completed, not supported, not supported. O2 sensors not completed. EGR system not completed. Whenever it would make it through all the monitors, but this one here would never complete. Do you think it's going to complete for us? This time, it's real time. I have not tried to get it to complete a monitor yet. So this one, I'm taking you guys along with me. We're going to drive it. I'm going to let it run its monitors, and when it completes, or if the check engine light comes on, you guys will know right with me. Well guys, I made it to Quakertown, which is about a 15-minute drive for me. Usually the light would have came on by now. I'm afraid to check the monitors, so I figured I'll pull in here. We'll see what monitors went through and see if it's even capable of doing it in one drive cycle. I know before I would make it like halfway here, and she'll trigger off the code. So far, no light. Let's see, I think there's a pizza shop over here. Bring this bad boy up here. Moment of truth. I tell you, if it went through, I will get out. I can't dance, but I will attempt to do the happy dance for you, whatever that might be. Woohoo! She went through, guys. Now that's a good feeling. Man, there's people walking around me, but I want to shout. And excitement, man. God is good. I just noticed I still have my drop light on down there. Oh gosh, I guess I owe you guys a dance. Alright, finished the plain slice. You gotta get plain just to see what it's all about, right? It was really good. This is Giovanni's, I believe that's how you pronounce it. What am I here for? Oh, that's right. I promised you guys a little happy dance. Even though I don't know how to dance, I feel great. There's a lot of people around here, but I guess what? They can't take that feeling away from us, right? And I made that promise. If it worked, that I was gonna give you that. Like I said, what's a happy dance? I don't know, but I know the lawnmower, right? I know the windshield wiper. And how about the weed whacker, right? That's all you guys are getting. That's it. That's all I got. All right, guys, we're back at the shop. I'm gonna see if there's any current codes. All right, no codes pending. We're gonna go out of here. We're gonna go to generic function. That's where you can most times find your readiness monitors. We'll see if this thing's ready for inspection. If it is, I'll run it through emissions and let you guys see it through. Test complete, test complete, test complete, test complete, test complete, everything. Let's see if the state is happy with it at this point. Moment of truth. Did we fix it? Were we good enough? Bam. Just looking for a sticker number and a date. That's a good sign. She's passed the emissions.